Hi, I'm Dr. Durie. I'm one of the family docs over at the clinic, and I work both in Metlake and in Tower. And today I thought I would talk a little bit about the COVID vaccine because it's a new vaccine. People have some questions about it. What's different about it, and how do they manage to come up with something so quickly when all along they say a usual vaccine can take so long? And I think people have a lot of legitimate questions about that. So I thought I would start by talking a little bit about what traditional vaccines have been about. You know, the ones we've been getting for years, measles and tetanus and influenza. And historically there are basically 2 to 3 different kinds of vaccines. And the purpose is to safely expose your body to something that it recognizes as an outsider, right? So take something like influenza. If we were to get exposed to influenza, your body knows that it doesn't belong there and it starts to fight it off, but it takes a while to do that. It's got to go through a whole bunch of processes to recognize what's foreign and then to mount a response to it. And part of that, and immunology is really complicated, but I'm going to try to simplify it. And part of it is the production of the right antibodies, okay? So when you get an infection, like influenza, there's a race. It's your body trying to come up with a fix and to eliminate influenza. And all this time, the virus is multiplying and causing the problems that it can cause. So if influenza gets the upper hand before you can find a solution, you can get really sick. So the idea is to get your body prepped for these things so that when it sees the true infection, it doesn't take as long to come up with the right response. The whole idea behind vaccination is to get your body a head start so you can fight something off faster before the infection gets the upper hand. And one key factor in that is that once you get an infection of the types that we have vaccines for, and once you come up with the right antibody to that, you'll have some level of immunity for a long time. Sometimes it's a lifetime. And sometimes it may be for 10 years, like a tetanus shot, you need a booster. So you get the infection, your body mounts its response. Now that response, what it does is it's randomly generating antibodies, okay? Antibodies are like keys. If the infection is the lock, the antibodies are like a key. But instead of really knowing what kind of key you have to make millions of them until you get one that fits. So it's kind of a long, almost a random process. But once you find the right key, then your body, you can replicate it, and you can clone it, and you can make millions of them. And they will attach to that invader just like a lock, just like a key going into a lock. And that allows your immune system to then, whether it engulfs it and gets rid of it, or and other methods, once you get the antibody response, it can get rid of the virus that's infecting you. And then those antibodies go into a memory. So it's like having a clone army that's now standing by on hand, so that a year from now, if you run into the same infection, these guys are ready, and you don't have to go through that whole process of randomly coming up with the right key. They're ready, and so you can fight it off right away. And that's the idea behind vaccinations. Now the traditional vaccines, there's a couple of kinds. There's one which is where you take a virus, like a flu virus, and you change it so that it can't replicate. It's like clipping the wings of a bird, okay? So, and in fact, in influenza, you're actually killing the virus. So you're taking a dead version of the virus, but it still looks the same to the body. So once you put that in the vaccine, the body goes down this whole process of coming up with the right antibodies, and when they match, it eliminates this virus which can't go anywhere anyway, because it's dead. But you save that immunity, so when the real virus comes along, you're ready. Okay? And then they have another type of vaccine which you take, and this would be true for tetanus, you take some of the toxoid, the poison that tetanus releases, You change that so it's no longer a poison, but parts of it look the same. So the body comes up with antibodies to that, so that once you are exposed to the real tetanus, you're all ready and you can fight it off. The problem with a lot of vaccine development and what takes a long time is that, for example, for influenza or for measles, all these, you actually need to grow the virus. And you need to replicate that virus, and that process takes a long time because there's a lot of steps involved in that. What's new in the new vaccine is that they have been able to bypass that. So you've probably heard it's called an mRNA virus. And mRNA is simply a template for something, okay? When viruses or proteins are produced, everything is coded. You know, you hear about our DNA being our code for everything that makes us up, and that's true. And viruses can be also made up of DNA. Some are made up of another molecule that's closely related called RNA. But these are just long strings of molecules that code everything that makes us up. Now, when you have an RNA virus, it just means that it's a virus that's coded by an RNA molecule. And when you make a vaccine that's an RNA vaccine, instead of taking the actual virus and disabling it, you know, or using a live virus vaccine, they actually just use the template for what makes up a specific part of that virus. In this case, since part of the COVID virus does show signs of mutating, there is one protein that they have not seen mutation in, and that's the spike protein. You may have heard that mentioned on the news, but the spike protein is on the shell of the virus. If you've seen pictures of it on TV, there's all these kind of things coming out of the ball, all these spikes coming out. That's the spike protein. The virus uses that to attach to cells in our body, and that's how it gets in. So we've found the code for that. We found the RNA code, the genetic code that makes that protein. So when you have a string of RNA and you use that as your vaccine, then what you're doing is you're injecting a template, and your body will see that, and it will actually build a spike protein. Now, a spike protein by itself is not a problem. Those don't cause infections. It's just a protein that would be floating around. But your body recognizes that as foreign, and so it can make that antibody response, and that would give you the immunity. That would get your immune system ready, so if you encountered the real COVID virus, it would spot that spike protein on it, recognize it, and you right away begin to fight this off, rather than waiting that few weeks it may take to develop an appropriate immune response. Now, there's questions people have about that, and they're saying, well, is this mRNA vaccine, does that get into our own genetic material, and are we going to keep making spike protein and so forth? And no, that's not the case. This is just something that's going to be, it lasts probably a couple of days, but in that couple of days, it can actually enable the body, our own bodies, to produce these spike proteins, again, just taking different proteins and putting them together in the order that's dictated by that template, the mRNA. So we're going to actually produce within ourselves what ordinarily you would inject for a vaccine. Okay, and then once you've done that, it goes away. It does not become part of your DNA. It doesn't last with you. Now, when I first heard about new vaccine and we're going to get it out before Election Day and all that, I was, of course, worried, well, is this being pushed through too fast? Or are they coming up with something and going to push it through quickly because of political reasons? Because to me, you have to separate science from all that, you know. So I was looking into it, and this is actually not new technology. They've been looking at mRNA vaccines since the 1990s. The problem they have had is that it's very hard. The mRNA protein or molecule is really unstable. It's hard to keep that from just disintegrating, falling apart. And that's been one of the really big obstacles. So the first vaccine that's come out, which is the Pfizer one, you may have heard that you need special freezers for this because they have to keep it cold to almost 100 degrees below zero. Not too many fridges, not too many freezers can do that. Dry ice, I believe, is just over, or a little bit more than 100 degrees below zero, so dry ice works, but only for so long. Moderna, which is the one that's coming out a week after, or it's being looked at by the FDA a week after Pfizer, they have found a way to stabilize the mRNA to a much more achievable cold temperature. And it's kind of in the range of our normal freezers. And then once you take it out of the freezer, you have a period of time where you can still keep it in a refrigerator for a period of time that makes it very usable. This, of course, is huge for distribution because right now the only people that have the really cold freezers are, I want to say, Walgreens and CVS. But we're trying to distribute, millions of these. So Moderna kind of gives us a little more leeway to distribute that.
Oh.
They've done, well, they do the phase 1 and phase 2 trials are where they're looking for adverse effects, and they figure most vaccines will have adverse effects in the first 60 days probably. Now, right now, it's the usual, soreness at the injection site, maybe under the weather, maybe some kind of, I say flu-like symptoms, but it's not flu-like symptoms because of infections, because you're mounting an immune response. They haven't seen anything worrisome coming up out of this yet. They're going to be watching really closely once they start releasing it. In fact, I've heard there's all kinds of protocols they're doing with follow-up and to be checking in on people, because really, yes, they've cleared the first 2 phases of the trial, which are their safety phases. But like anything else, once you open it up to a few million people, then you'll see if there's really anything that's maybe way less common, but still may be significant. Right now, they think it's a safe technology. So the first wave of vaccines, and they're intending that the first people getting it will be healthcare workers, and I think it's really probably a subset of that. I think it's the people who are going to be working closely with COVID. I have heard, in hospitals that may include food services and may include janitorial. I don't know, depending on how many there are, if all the clinic staff will have availability of that. The next wave is going to be your high-risk populations, and they're starting with nursing homes because the numbers are so high there. Once it gets in, it's almost, they do the best they can in the nursing homes, but once COVID gets there, it's almost like being locked in a lower deck in the Titanic, So they're trying to address that population, which will also, since most of the really sick folks are older, that may prevent some of the illness that's causing a lot of the hospitals to be overloaded right now. Beyond that, I think they'll be ramping up production fast as they can and distribute as fast as they can. I don't have a date for when it will be available. I don't know, Sue, if you have heard anything on that. No. In your conferences. But it will be easier, with Moderna, if they get the thumbs up from the FDA in a couple of weeks, just because it's easier to keep something that doesn't have to be maintained at that temperature. Okay. Yeah, and they're going to come up with a mass distribution plan once the immunizations are more widely available, and there will be updates locally here in the community, so everybody can be on top of that.
Good.
You said the spikes, which are the outside shell, right?
Yeah.
That don't mutate.
They haven't seen that mutate yet, and that seems to be critical for the virus to infect. So almost, if that mutated, it might hurt the virus to do that. Mm-hmm. So far, that has been one very consistent piece of it.
But if that were to change,
If that were to change, then it could go two ways. If that changes, that may make the virus less effective, right? I mean, that's one thing that is made it very effective. But it would also potentially render the vaccine ineffective. And I think what you're saying, I can also tie that into people who have had COVID. Because once people have had COVID, we have seen that people can have immunity for a short period of time. And that may be 3 months. For some people it may be quite a bit longer than that, but for some people it may be shorter than that. And we don't have a really good way of monitoring that. But when someone has had COVID, you know, the question comes up, do they still have to, you know, bother with the whole masking thing? And I would argue strongly yes, because for two reasons. For the selfish reason for yourself, you should, because you don't know how long your immunity lasts. But I think more importantly, recognizing that we're all in this together. There are still some people who don't believe in masks. There is science that supports masks. There's studies, one just came up from Mayo, that masks work. And if everybody was on board with that, I think we'd have less of a problem than we do now. But if you have people that are mingling in the crowds and not wearing masks because they already had COVID, or maybe because they had the vaccine, it really sends a mixed message to everybody else who thinks, well, you know, people don't really care about it. I think it's important to maintain the consistency. Once we have immunized enough people, yes, masks are going to go away. You know, you have to reach a certain percentage of the population to achieve that, though, and we're not there. We're not close to being there. The hospitals right now are really being taxed. I mean, a lot of them are full. There's hospitals on divert, not just for COVID, but for somebody that comes into the heart attack. Sometimes there just isn't a space. So we have to keep it up. We have to keep up the masks. We have to do that until we have enough people that have immunity, until we know. And we'll get the word out on that too. I mean, that's going to be no secret when we reach that point. That'll be national news. You know, but we can't let up yet. That's really important.